All right, let's take another look. Current level C81B, that's up here. Yeah, there's some stuff here, C81B. Why is it offset? Okay, that window is broken. Is it? That's strange. My mouse is offset. That's weird. Okay, that's better. Yeah, that's fixed. C81B is the current level, C81B. Right, so if I change that and finish the level, then we should warp there. I do want to check where that value is set. So I want to put a watch point on that. The goal is to make a function or like a button I can click so I can warp to a specific level, because that's going to come in handy when I have to test stuff further down in the game, of course, right? I've only been testing like the first 4, 5, 6 levels, but yeah, we'll have to look at other levels too. So yeah, let's see. I mean, we can put that back, and let's see where if we can put a watch point on that, where that is actually written. No, C81B. Is it dollar or yeah? That works. Okay. So I'll finish this level. I mean, I can just load the exit state. Then we can get immediately there. So that should write 2 in it somewhere, someplace. And that didn't work. That's crazy. Oh yeah, it removed my watch point when I loaded the new state. That seems to be like a bit of a bug. I mean, it depends on how you look at it, right? But yeah, let me re-add that. C81B. Yeah. And let's exit again. And hopefully now it breaks. Yes, it does. Yeah, so current level is incremented and set. Well, we're incrementing over here straight to the value of HL. We'll increment that completely, but we are loading that and comparing it with 6A. That seems to be the end, maybe 6A. Let's see what that is. I mean, 64 is 100, so that's 105, I think, which would be the end of the game, right? So yeah, that's 106. So 105 is the last level. So we increment, check whether it's 106, and then we just go to the main menu over here in this line. So this function looks to be handling the exit of the level. Actually, we do have to find a function that loads the level though, because this just sets or increments the current level. But we have to find a function we can call. So yeah, let's continue for a moment here. So we're loading the value in A, which is 2 now. It's up here in the A register. And then we're comparing that with 6A, that's 106. If it is, then we will show the main menu. We don't do that now. C81B is again the level. That's weird because we already have the value of the current level into our accumulator. Right, so that doesn't change anything. We're loading 1 into C, sure. We're ANDing A, checking whether A is 0, I guess. And I'll have to look that one up. That's a jump M. I haven't encountered that one. So if the signed flag is set, so it depends on the signed flag. Okay, which is unset, I believe now. And we would jump to 4721, which is the end of this function. Well, it jumps farther away, okay. 4721 is, don't think that's going to happen. It does indeed not. It's compared with 6. This is going to be determination of bonus level, perhaps. I mean, why would it be 6 though? Because we have a bonus level every n amount of levels, every 5, I think. So yeah, comparing with 6, conditional jump to 470D, so we're skipping these 3. Okay. If we would have taken the jump, of course, we're increasing C, subtracting 5 of A, JR of A value is, oh, the signed value of D, the signed value D is added to PC, so it's a relative offset. Well, I mean, we're not seeing the exact value here, but it is jumping to 4700, which is, right, it is looping every 5th, like it's checking whether we should go to a bonus level, I think. So we are indeed jumping. Oh yeah, it's a relative jump, okay. So we're again checking whether A is 0, which it's not. So that's to exit the loop, I guess. Because that means, yeah. Oh, it is now. Okay, fine. Well, let's follow this this jump here. And we're immediately calling another function. Let's follow it for a bit. This is score related. Okay, we're loading the top score and the game mode, which is 0, meaning type A. Checking whether it's 0, and we are jumping. Right, it's the difference between type A and type B, where we have to assign the score or something, or do something with the score, but it has to be the appropriate score. In other words, depending on the game mode, type A or type B. So we're loading 1859 into HL. That's a weirdly low number, and we're calling a function. Let's follow it for a moment and see where we end up. Okay. We're loading 0 into C, and the value of DE, which is C000, into A. Well, it's the pointer. We're loading something in there. I mean, this is starting to call lots of functions again. That's fine. We're adding the accumulator with 0F. We're not jumping, increasing C. And decrementing C, that's also quite weird. Well, no, because that has an influence on the 0 flag, I guess. Right, these are, so I'm going to look this one up. I think I have a list of this. Yeah, this is supposedly a list of the BIOS calls, and 4D should be in here. Yeah, that's rise data in VRAM. I have to create a symbol file for all these BIOS functions. But yeah, that does make sense. So the address to write it to, I guess, or the address to write, and then the value is 20, which, I don't know, 2042, is that score? No. Okay. But yeah, if I create a symbol file for this, for all these BIOS calls, that means we can easily see them here as well. And we return from this one, and then the next one. Again, we're just looking and see what happens, right? Okay, decreasing DE, C809 now. Okay, C809. Oh yeah, that's still the score. Okay, we're still looking at the score. Loading DE's value into the accumulator. We're doing some mathematics here. Okay. I think this is just putting the score on the screen though, because then we're doing the same thing again, now with probably this one here, maybe. Well, it's still on C809 though. Gonna jump over these. Okay. And again, updating something in the VDP registers. Increasing HL and returning. Okay. So this is indeed score related. We're probably doing the same. Yeah, we're calling the same functions with a high score, player 1. Not sure exactly what they do, but that's fine. And then player 2, even though we're in a one-player game, we do that as well. Get current player lives address, which would be C811, which was returned, which is indeed player 1 lives. Exchanging these two guys here, DE and HL, because we're going to call something 6B10 wasn't called yet, so we're going to look at that function too. 191C, also a weirdly low number, and 0. Let's see what this one does. Okay, this looks like the same thing as we were looking at before. This looks like a similar manipulation. Not sure exactly what it does. 6B15, is it the same? No, it's not, right? Let's look at 6B15. 6 being the amount of lives is the parameter of this function. It's added with 0f. Let's see what that does. I mean, it can be different whether it's signed or unsigned, I guess. I'll have to look in the calculator to look at the bits. So 6 is of course 2 and 4. So yeah, that's bit, well, the second and the third bit. And then 0f is everything, or the first bottom 4. Okay. This could also be a base or BCD related updating stuff. Yeah. I think this is the part of the BCD conversion, because these functions or these values are in BCD representation, I think. Right. Okay, so I don't think this is super important. And then we are popping a returning. Okay. So this is where we were, right? I think at least. Okay, let's see what this one does. Current bonus level and bullet count. Yeah, this is probably updating stuff on the screen, I think. So we're checking whether it's a bonus level and returning if it is. We're loading the bullet count. 195C. That's a weird number though. Because if you go look in the memory, 195C, that's not going to be anything. I think that's because we're quite low now. 195C, yeah, that's like we're in the middle of nowhere here. So that's nothing interesting. So it might be an offset of some sort. Because if you look at that value, yeah, there's like 6,492. That's not really anything useful right now. I mean, it could be an address in some sort of video RAM, or I don't know. 6B10 and 6B15 we've already seen, I think. So let's take another look inside. Yeah. This is the same thing. This keeps returning. I think this is BCD related. So we're going to exit this one. Because indeed the bullet count is also BCD related. Well, it is in BCD, right? So, right. Then we're jumping unconditionally though. Okay. And again, similar stuff. Okay. Oh, 141. Returns the value of the specified line from the keyboard matrix. Okay, I'm looking at 141 over here. So it is actually checking inputs here. Also interesting, but not really relevant. And it checks whether it's whether the second bit is set. Okay. Oh, and that implies that sets demo mode though. I wonder if there's a key that automatically starts demo mode that you can press while he's exiting. Weird. And then we have D2, D2. That's interesting because that's some memory over here that we don't know about yet. D2. Oh, that's quite down here. Okay. This is 7, which we are increasing. Well, no, we are D308. Oh, no. Okay, so we loaded the value of D2, D2, which would then be 07D3, well, D307 then, and that became D308. That's an interesting an interesting one to keep an eye on. Oh, and we are writing 40 in that value. So that's D3. This is a pointer, right? D308. Is now 40, will now be written in there, right? We're checking whether it's demo mode. We're loading player 1 lives into A, which is 6, increasing it, sure. Oh no, we're increasing the pointer. C812 now. Oh, and we're ORing that with a value. So we loaded 6, and as in the amount of lives. So that lives in C811. MSX, and we are ORing that with the next one. Because we have, we're ORing with the value of HL, which was incremented. So that points to C812 now, which is the next one. And what is this? Player 2 lives. Oh. Okay. So it's doing an OR between the two amount of lives. Okay. We're checking single or dual player mode, checking whether that's 0. And then current level. We are loading the value of the current level into A, which is 2 now. Comparing it with 65, which is 101. Okay, we're calling 3 functions here. We're almost at the end of this function. Well, I mean, it's jumping away though, but yeah. Okay, let's see what this one does. BIOS call 56. Fill VRAM with value, which would be a blank screen, I guess. Yeah, so A is a data byte, which is 0, because we are XORing that out. And BC is the length of the area to be written, which is hex 3000. This is interesting. We're gonna note this one down though. This is like a clear screen function. But I'm looking at the values, and that's interesting as well. So they are, I'm going to have to write this down. So because that is loaded into tilemap2, I mean, those are the implicit tilemap values, right? Or the dimensions at least. So 768. Can I open 2 calculators here? No. So 768 over, well, 11 or 22, that's not a whole number. That's, oh, well, no, it's not 11, because there are 11 tiles in the playing field, but it's everything, of course, right? So yeah, it's like 11, 12, 13, 14, 15, 16. And I think that's divisible. Yeah. So that's 48 wide, and 1800 is a height, I assume. Wait, was this? Oh, no, that's the start address. Okay. Yeah, so this is mapped in the regular memory, I think. So we'll take a look at this to see if, oops, if this indeed writes it to 1800. But this function will give a name first. So 6B53, we'll put that 6B, that's quite down, 6B53 in between these guys. This is, I think, clear screen. Okay. Yeah, because this loads, or this, no, it's 6, okay, it's a 5.2, right? Because we need the XOR. Right, so we're clearing the accumulator, we're loading the amount of tiles, which is, well, it's video RAM, but that does make sense. So, Nope. Nice this, and that was 768, right? Yeah, 768. So we're filling that with this function, and we are loading the tile map. Okay, let's continue. Let's do that first. Let's see if that automatically updates the screen. It does not yet because I'm still in break. I think it has to do that upon a refresh of the screen. So we're loading the tile map, C81E. Yeah, that's indeed the tile map, and that's going to be cleared, I guess. C81F. That's also weird because that's like the second entry in the tile map. And then 73 hex. And we're putting 0 in what HL points to, which is C81E. No, that's the started, that's the tile map, okay. Okay, so we're putting the first byte on 0, and then we're referencing the second byte in the tile map. That's weird. I'm going to look up what LDIR does. What does this do? Okay. Transfers a byte of data from the memory location pointed to by HL to the memory location pointed to by DE. Then HL and DE are incremented and BC is decremented. Okay, so this is, and then if BC is not 0, so they're subtracted from each other, and then if it's not 0, the operation is repeated. So it like clears the entire array. So it goes from, that's an interesting way of clearing memory. I've never seen that before. I mean, I'm sure it's used elsewhere. But yeah, so well, you transfer a byte of data, which can be anything, but the accumulator is 0, right? So that's still 0. And so we're so the memory pointed to by HL, which is C81E, which is the second byte of the tile map, and then from the memory location pointed to by HL to the memory location pointed to by DE. So EF, okay, that's only 1 byte. Then HL and DE are incremented, and BC is decremented. Okay, BC would be the end then, or that's just a counter. Yeah, that's the counter. Because we loaded 07E3 in BC, which is weirdly enough not 07E3 now. I wonder what that's about. BC is decremented, which is 04F3. That's weird because we literally loaded 07E3 into BC though. That's maybe a special register. Weird. We're loading 0 in what HL points to. Let's see what happens to the map, whether it happens in one go. I'm assuming either one by one they go to 0, or it's like entirely zeroed out. It's entirely zeroed out, right? So this not only clears the screen, but clears the map as well. That's an interesting little function. And if we look at the size here, 7E3, that's 2019. Okay. So we clear the screen, Oh, and Lolo is still on there. Well, which is a sprite. Okay, the sprites haven't been removed yet. Maybe this one clears the sprites. Let's take a look. $1,800. Okay. Let's see what this first call is doing. 6A, 2C. Okay, this is looping. This happens quite a while, over 10 times. 4, 3, 2, 1. Also in a loop here. Okay, let's escape. Not sure what that one does, but that's fine. Let's look at the next one. 0056. Again, fill VRAM. I need to put these in a sim file though. Again, fill the VRAM with values, so we are putting something on the screen, I guess. D1. Okay, I don't want to be in this function, but that's fine. It didn't put anything on screen yet though, but sure. 412C. Immediately call in something else. Oh, that's the same thing. Okay. D005. Wait. Is compared by 2. Let's force that value. Again, an unknown. Again, this one, okay. Okay, let's manipulate D004 and D2D2. Let's see what that does. We can force something here. I'm going to disable this one. D2D2 is now D6. Okay. Oh, this might be that's quite interesting. So this changes on key down and key up. And if I put it on 0, it tended to kill me. That's weird. Not sure what that's about. Okay, let's look at D004. No, it doesn't allow me to register any inputs. Okay, so this might indeed prevent inputs from being processed. Wait, did I change something on the screen? No, it didn't. But yeah, I can't do anything. Can I do stop? Yes, so it's just movement perhaps. Yeah, that might make sense in a demo mode situation. So let's do that. Let's go back into demo mode. I'm going to control stop. So I'm going to the main menu. No, I wanted to control stop. Right, so D004, let's see if that turns into 1, meaning we're in demo mode, no input allowed. Oh no, I need to reset for that, because otherwise it's going to be, I wanted to play the actual demo, the built-in demo mode. I mean, it didn't look like it changed though. So I wonder what writes that. Yeah, no. And of course, if I press the key now, it will go back to the main menu. It doesn't affect the demo mode. Let's see if we can. Oh yeah, I know it doesn't let me. So it is input related, but it prevents me from doing input at all. Wait, can I not? Oh, is it because control is held? I mean, I don't think space worked either, though. Let's try that again. I did press space and it exited the demo mode, but when it was on 1, it didn't. So let me put it on 1 and see if I can exit. Yeah, no, I cannot exit. And if I put it on 0, it does work. So the question is, where does that get set though? Is it anything to do with construction mode? No, because we need input, right? I'm going to put a watch point on that. Error, no, okay, that makes sense. Never mind, reset. I am going to put a breakpoint on D004 to see if that ever gets written immediately. Let's see if that's just in the main menu. Okay, it was active in the main menu though. I didn't look at the value. Perhaps we have to look again. Okay, so let's do type A. Let's see if it gets written again. Okay, still. And this one is also input related, like all of these, I guess. Okay, this one turned 1, sure. That is weird. I'm going to do a level transition to see whether it perhaps stops keyboard input when when it's jumping up and down to celebrate the finishing of the level. Perhaps, like when we move over the exit, that could be the case. Okay, exit is open. Does it get written? No, it does not. Very weird. So it only appears to work or appears to be changed in the main menu. Wait, no, I stopped. And now it gets written. Oh, now it's 2. Yeah, now it's 2. Okay, very interesting. Now it's 1, so it's a bit of a timer, I guess. Two, 1, 0. So it's like a bit of a. Why would it be like? Because we have to press spacebar here, though. I mean, spacebar works, and that was also affected by that variable. So I don't know. Let's see what happens when we put that thing on 2 in the level. Wait, I'm gonna give myself bullets though, so it shoots in case. Okay, no. That's weird. Wait, did the snakies stop moving as well? Yeah, they do. Oh, no. Okay, no. They're still moving. Okay, so that's at least menu related then, for some reason. Let's add it as a variable. It's interesting, like is spacebar held? Doesn't need turn 1 for a fraction of a time, but this is actually is spacebar held, I guess. But yeah, let's put D004 here. And that should be input enabled. 0 is enabled. Goes or values scene 1 and 2 as a timer in the menu, the main, well, not the menu, but the intro screen. Okay. Yeah, this one becomes right. I can trigger. So this is a result though, like has like this only stays 1 for a moment here when the spacebar has been held. I think this is more is spacebar pressed, and this one is should act on spacebar pressed, because this stays how are we going to describe this? Okay. Okay. So yeah, that's should act on spacebar pressed. I'm assuming this also works in menus. It does not. That's also interesting. Not even here, so that's actually only in game. Right, as soon as this becomes 1, I assume. Yeah, so let's try something else here and put this one on 1 in the main menu. Oh, it doesn't want to do that. Okay. Okay. Let's look at the level number again. So we're going to break on, wait, so we looked at D004, which is whether the inputs were enabled. And we looked at D2, I think. Yeah, this one, which doesn't seem to affect much, but it can kill Lolo for some reason. Is it when it turns 10? Yeah, or 16 perhaps, or yeah, 16 was it, right? Yeah, that's strange. So when this is 16, Lolo dies. And this number, like this increments, right? So what happens if I let it overflow until 10, until 16 decimal? Let's see what it does now. Oh, that's, is it because it's an odd number? Weird. Okay, I want to look again at the around the current level. C8-1B. I want to look at it when we load it from the main menu. Is it going to remove my... No. No, I'm not going to take the first one, because that's going to do lots of stuff. Okay, from now onwards, this has to be put onto 1. And I wonder... Okay, I wonder what's going on here. So we're increasing though. So we're loading C807 first, and we're increasing that. That would have been initialized to 0, I guess. C807. Oh, is this the next level? Oh no, current level, and the other one is next level. That's interesting though. It comes from this. So let's keep an eye on this variable here. Let's disable you and continue. Or does it have anything to do with this, perhaps? So if I'm going to put a different value in here and see if we skip to level 51. And this is the score, okay. So yeah, I put that on 50, but the current round didn't change, right? So I wonder now if we will skip to level 51. No. This might then be the result of the password thing. Right, so let's reset. I'm going to enter a correct password and see if this number gets updated. Does it get reset to 0? Yes, it does. So let me find a password here. I have to find the correct one because these do reference different ones. Yeah, this is not the one we want. Okay, let's put this on the favorites bar, and then passwords is this one. Okay, let's just pick one. I'm going to assume that I will be able to read this. Lala left, facing left, Alma facing right, Medusa IN, which is, where is it? Medusa inactive, okay. Snake left, snaky left. Wait, which one though? Snaky left. Snaky facing left, looking at player. Facing left, looking at player, okay. And then goal left, goal facing left. Wait, did it change? So yeah, it didn't change yet. It should change to 21, I assume. Oh, it didn't. Then why was it checking this value? Like, that surely can't be a simple 0 though. Okay, so I want to try putting a value in here. And see if now we go to level 21. No, very weird. So, I mean, let's reset and enable this guy again. Because why would that memory have been checked? Okay, so this is resetting this one, sure. That's before the password. Oh, okay, that was before the password stuff. Okay, so I can do that before. Wait, it increases the accumulator. Now current level is 1. Okay, that's fine. Again, D864, something we don't know either. D864, that's quite down here. Wow. D86, oh, this could be related to level loading though. D864. Yeah, these are the levels, I think. So at that point, we don't write any values in that anymore. I'm going to attempt to write this value just before we have come into the enter password screen to see if we can force the level. So that would be, I mean, here, right? Okay, it gets reset, that's fine. And yet, oh, wait, C807 is written in here. Okay, sure. Also, this isn't correct then, because show main menu, like it goes on here, it can jump, of course, like it can do all those screens, but it doesn't just show the main menu, because it does initialize here. Like, yeah, we're setting 8 to 0, and then putting that into demo mode, current bonus level, and this level. So this has nothing to do with our current or next level or whatever, because we're resetting all these specific values here. But I am intrigued by C807 though, so I do want to see what rides there after this one here, after like the initial the initialization. C807. I have to put a thing here. Yes. Okay, let's see where else this gets applied. It wasn't in the password. I'm going to skip this and go here to a level transition. It doesn't get written. Perhaps when we go into a bonus level just before, and that would be this one, right? I didn't say, oh yeah, I did. Okay. Scores are updated. No change in the bonus level. Not written here either. We have our password, which I'm going to screenshot. Well, the special word too then, okay. Okay, so we can close this. Well, we can minimize this. And again, not written to. Is it red though? Oh wait, crap. With me loading the states, it removes these watch points, and that's quite annoying though. Crap. So I don't know. I mean, I did that for nothing because the watch point wasn't even there. I'm gonna check whether it's red in a level. Which it apparently is. I mean, no, because I'm already doing it wrong here. No, I want to go to the exit of this to see if the transition works right. So level 1 just before exit. And then let's see if this is, first of all, written, yeah. C807. It is not. And then I want to see whether it is read from. Okay, so we can't get it to trigger. Perhaps it has something to do with mode B. So let's check that real quick. Continue. It doesn't appear so, at least not when playing the level. No. Very weird. And it doesn't seem to have any influence either. Nope. Okay. it would be handy if we could search for references to certain addresses though. Okay, fine. I want to look at the level number again then, because that's what we were looking at, right? This is the map. Still curious about what this is though, unless it's like OT 02000000. But yeah. And this is the water map, I think. Yeah. Current level was, I always forget, C81B. Oh yeah, we still have that one. Let's see where it's written again. Let's play this level. I'm still in B mode though. Should change over to A mode. Okay, so same spot. We have loaded the current level, we're incrementing it, and we're loading it into the accumulator to compare to 106. Because there's only 105 levels. If it is the case, we go back to the main menu. There must be something here that triggers the load, unless that's in the function above. Let's see what is above here. There's nothing above. Also quite interesting. So that would have been quite a high up function then. Where would this one start though? So yeah, we were here, right? Yeah, we were here assigning the current level, current bonus level. I mean, it XORs out the current bonus level. That makes sense. Handle successful exit. We did do that. So if I set the PC to here, it does the little jumpy thing and goes to the next level. Yeah, it does increment a level. But I do want to be able to put in a level number though. I mean, I can jump here, of course. If I jump to 46F8, then I can force the round number that I want. Right, so if I break here, which it doesn't break on, but if I jump to 46F7, wait, question is, can I force the A register, or do I have to put it into the memory? So I'm gonna scroll here, and I'm gonna put, so now, wait, so the value, well, we're in 5, so yeah, it's confused, I guess. It can't, yeah, no, I can't do that. Because if I continue, it's gonna crash probably. Yeah, it doesn't know what to do with that, because I just jumped the program counter to a completely different thing. So yeah, that doesn't matter. That doesn't work at all. So I guess it'll be hard to make a warp function unless I can find something that reinitializes everything, which would be after the password thing though. Like if I put in a password here, so this one puts 1 in current level, okay, Yeah, because we're incrementing and we're putting, so we are resetting these three to 0, unknown what C807 is, and then we are incrementing it by 1, so we're at 1 now, and then we're putting that in the current level. But this can change. Okay, I'm completely messed up, it seems. I don't know why that's the case though, because I did reset. Wait, let's try that again. That's fine. We are resetting. Type A. We are breaking. That's the initial set. I'm continuing. Oh, it sets. Apparently it does a second set here. We are incrementing A as well. So we're putting it to 0. We're calling AFE3 for some reason. AFE3 is not a bit down here. AFE, I mean, I could have jumped this one here. A into HL increment. This is a little loop. D864. Again, I think we've seen this before. Let's see, this seems to be the root of the levels. I think these are all the levels here. Or the current, no, this is not the current level. Or it could be the current level as in without tiles though. As in the actual IDs of the enemies and Lolo and stuff. Because yeah, this loops. AFE3, it loads A into the value of HL, increments HL, like this loops until while it's not 0, right? Okay, see if we have another one here. No, let's take this one. Okay, I can't click, of course. Right, from the moment it matches, it sets the round. So this is a live number. Okay, I can force this because I can do a backspace. And this might be a good function to jump to, if that would work. Okay, what are we doing here? I mean, this calculates the password and the corresponding level number, right? I guess this has to do a lot. I think this is where we were though. Load A into current level, yeah. and then call AFCE. What does that do? All right, so this loads FF indeed, because that's the accumulator into current level, right? It just says here, right, if the password is wrong. Okay. That's fine. So that's not gonna be the trigger to start a level though. Yeah, so it compares with FF here. So let's go to a certain level. Wait, what did we, did I break on something I did myself, I guess. And then let's run here. Wait, are we gonna run here or NG? Okay. That's fine. Let's see if we can run here. No, we cannot. $85. Okay, so it did update. Right, that's the update routine, I guess, to put the number here. I don't see a way to force that number and jump somewhere where we can load, because it doesn't use a function to, or at least I haven't found it yet, that actually reads the current level and then starts loading it. Like the writing is one thing, but actually we need to know where it gets read, and then we will perhaps end up in the function that loads the level or resets the level at least. Okay, we've set it to 1. It hasn't been read yet, but now it didn't though. So, well, so what happens if I clear the level though? Oh, it's not active. Okay. And it is read constantly. I guess that's to update it on the screen perhaps. Yeah, because I think that happens every frame. Yeah. So if I change that now, so A is now 1, right? So let's change that. And let's see if we can put, yeah, so this, if I change this to 40 and let it continue now, it will probably update the display to 40, yeah, well, to 64, of course, 4 times 16. Yeah, so it does read the level, the current level number, just to put it on the screen every frame update. So that's not the one we want to. Let's see if we can, yeah, it's a register, so we can do a condition where we say the PC shouldn't be this. Can we do that? It might be BC though. I don't know if that's yeah, let's try BC, because that's the one where it actually gets written, gets read. Yeah. Okay. So now when we exit the level, it should give us the position where the level number gets read, presumably to index into the maps array or whatever. But that would be the function that is called when a new level is initialized, loaded. I mean, we should have already seen this because the clear screen we detected earlier should have been in that function, I assume. I also don't know how many times this value is going to be checked. But yeah, here we are. So okay, that's the, so we have incremented it. So we're wait, where are we? Yeah, so we're loading the current level into the HL register. We are incrementing the value of the HL register, and then we're comparing to 64 just to see whether we have to skip to the main menu. Now I'm going to continue. If it jumps out and continues, that means that this is the only area where level number checking is done, and that would be for 6F7. Let's see. Again, we load, wait, for 6F7, that's the same position, right? Now, yeah, that's the same thing. And then after that, so it's every time, because HL points to C81B, which is the current level number, every time that value is loaded now, in this little section, it is it's breaking, of course. So now we're comparing, so we're loading it. Oh, and we're loading one into C. That's strange. So I'm going to see what the relevance is to the AND and the C register. So we're doing AND C, comma, I mean, do we have, no, we don't. We have no argument here. Yeah, bitwise and on A with C. No, we don't just do, we're doing A. Yeah, it's A on A. So that's just checking whether it's 0, right? But why would that be 0? Because it's the level number, it never gets to 0. And now it's comparing it to 6, determining whether we have to assign a bonus level number. That's fine. I'm going to play again. Now it's compared to 101. Those I assume are special levels, because those are the 5 last levels, right? For which you have to, I think, enter the special bonus password. Okay. Oh, that's interesting. So now the level cleared. We're loading the current level into A and calling a function here. A, so we are at 6, 7, 16. Let's see what this one does. Okay, bonus level is loaded. 6D56, that's slow, right? That looks like a pointer. We're checking whether the bonus level is 0. Then we're loading the current level, okay, which is 2. We're decreasing the current level, comparing it with 5. So that's whether the previous level, I guess, was 5. D5, F8. We're indexing in this. Five bytes in as this one indeed. I mean, this simply bonus level checking though. I think maybe this was determination whether it's a bonus level. Okay, so current bonus level is 0, of course. And we're not doing anything. Okay, again. And then D8, 7B. And D235. Oh, we're removing stuff again. So this is level initialization though. Like how else can it be? Six, 7, 16. This looks to be like we're checking whether it's a bonus level. Like yeah. We're loading 1 into bullet count. 23 hex into the level timer. Yeah, how is this not level reinitialization? Yeah, like it's putting HL into Lolo's position, facing direction. So now it's like this. Let's let it clear though. So it's clearing from D87B. Well, do D235. So I'm assuming this is all going to go. Let's let it do the LDIR thing. No, so it doesn't remove all that. That's fine though. D88A. Which is 8288. Okay. Yeah, this is definitely level loading. And we're calling something which fetches, I assume, I mean, if 8288, which is 8882, would point to the current level we have to load, perhaps. 8882. If this is this level, that might make sense. What are we in? I don't know which level we are in. Level 2, I think. But yeah, I think we're in the right position. So I think 6705 is going to look in this array and check where Lolo's position is. And let's see. Let's So HL is going to change and going to contain the position of Lolo in this level, I think. So let's see what that becomes. Yeah, 0824, and we were at 88. Can't remember. So 2408. Well, no, we can't determine that because I don't know the ID or whatever for Lolo here. Okay, and the direction facing is 5, sure. It's not a bonus level. D88B. Wait. 8882 was it? Okay. Right, this one. So let's keep that too. And let's go back to D88B. Oh no, that's not an address because now we're loading this second one. Okay, and we're calling another function. It's the same function. Okay, so 6705. Okay, we're gonna have to look into 6705 though, see what that is. That is pretty short. So it gets 88 as an input, all right? We're loading A into H, ANDing it, okay. Let me do that real quick, just to see if we understand correctly. So we have 88, we're clear. 88, and 0F is 8, that makes sense, right? So we're taking the bottom part of the byte. We're doing times 2, that makes it 1632. We're adding 2, this makes 34. Let's see if that's correct. Yeah, that becomes 8. Then becomes 16, correct. 32, which is 20. And then 2 is 34, which is 22 hex. Loading A into L, 22. Oh, right. It converts an index into an XY position, I think. Yeah, that's I think the case. Yeah, and then we do F0. So yeah, of course. This does the bottom part of the byte, and this does the top part of the byte. And for the top, we do rotate right twice, which is times 2, and does that, and add 4, and loading that in H register. So that's 88 is the position of the exit, and 82 is the position or the index in the map of. So this is Lolo's position or Lolo's wife. No, Lolo's position, and this is the exit position. Question is where did we get those? Okay, that's very interesting. So I think it was this one, 6705. I think this is just convert map index to XY. And we're going to double check that by see whether the values make sense. 6705. So calculation, well, so conversion of a position index in the map to its corresponding XY coords. So index and the bottom part times 2 times 2 plus 2. 88 is, wait, this is for the Y chord. So we do 88, which then becomes 8 times 2 times 2 plus 2. We're in hexadecimal, which is 34. And then X chord becomes index and F0, the other part of it. And we do rotate right and carry. That just means times 2. Rotate right is divided by 2. So I think that's divided by 2 plus 4. And for 8, that would become 8 times 2 times 2 plus 4 is 6. Let's see if that's correct. I don't know. So yeah, that's H, which H was in, we load H in A. Yeah, that's for the next one. A is this. The result is stored in L, which is 22. Yeah, that's 34 hex decimal. So now we take 8. Well, it becomes 80 though. Oh yeah, that makes sense. Yeah, of course. That my calculation is wrong. It's not 8. It's 80 hex. So it's 80 hex times 2 divided by 2 plus 4. Is 24 hex, which is 36. Yeah. And that was 24 hex. So let's see if that becomes 24. So rotate right at 4 is 24. Yeah. Hex. And that is the result. And that gets put into the Exitor Y. Yeah. We have we load our indexes and we convert it to XY positions. So the result is in HL 22, 24 for XY. That's 20. Well, yeah, right. 24 is 36 and 22 is 34. Yeah. Correct. Yeah, I don't think we can jump here though, but this is definitely the function. Wait, no, where are we? What, I have to note the start of this function though. Yeah, this one, 6716. That's the interesting one. We're going to give that a name. Okay, I thought I already did that. 67. One 6 is initialize level or round, I guess. And that does not take a parameter. It loads it from current level. Let's see where that all is called. I'm going to let it run now without this breakpoint or watch point, just 6716. And I'm going to reset. I mean, yes, I guess. Wait, did we save and reload? Yeah, initialize round. We still have our breakpoint. Yeah, so it first draws the outer part, the menu, the like Chrome, so to say, and then it initializes the round. That means I can't really call this function because it expects the Chrome to be painted already. But it is an interesting function nonetheless. Okay, we're looping here, 6, 7, 6A. That's this one, okay. Let's see what this first function does, this A824. Okay, is it a bonus level? And then we're loading 65.6 though. But I don't think we A8, so we're taking this jump. Otherwise, okay, so yeah, this is, so it's two, there's two options for HL. These should be pointers to the arrays that contain all the levels, right? Because if it's, so we start a function, well, we check whether it's a bonus level, but we initialize HL first to the regular map pointers. If it is a bonus level, then we don't jump, and we initialize to 6D80, which is the offset of the bonus levels, because they have a different numbering, as in the regular levels go 1, 2, 3, 4, 5, 6, but between 5 and 6 is bonus level 1, so they're separate in the data. So I assume these are the pointers to the map data, right? The 105 levels plus 6 of the actual data. So let's take a look at those. So 65.6 would be the normal levels, and that's quite low in the data, I assume. So we're at function still, right? 65.6, this might be the start of the data. So what is this? Spacebar press, these could be utility functions that they put at the back. 6D56. It's weird that it starts at like an odd number. Not super aligned, but sure. So we're loading. So we're going to probably index in this array a certain amount. It would be interesting if I could like draw this out better, because I'm pretty sure we're going to reveal the actual map. I mean, you can't really see it here, of course. And then we're going to try changing something. Can I change these values, or is this a ROM? I cannot change this. I mean, it makes sense that they are in the ROM, of course, but we're going to have to use the hex editor for that, which is no big deal, because we're going to try changing the level a bit and see if we are correct. But assuming this is the root, like the pointer to the entire array of 105 levels, now we will probably index into that. And if, of course, seeing as the level number is 1 based, we have to decrement to compare it, or to index into this array, right? Because the array will be 0 based. So yeah, that's what we do. We compare it with 5, that's irrelevant. That's to do something with bonus level or something, I don't know. HL65.6. Wait, I should have put these numbers. Yeah, I have to name these first to what I think they are. Right, it's going to be all the way at the top, of course. This is level data. Well, I mean, how are we going to name this? I mean, I guess level data is fine. And then we have 60, 80. Oh, we have to look at the difference between that, because no, it can't be, because there's not much difference between 65.6 and 60.80. Those can't contain the entire 100 levels, so this is definitely wrong. We'll see what is in between 65.6 and 60.80, how many there are, and okay. So, and because this would be bonus level data, right? I mean, it might simply, I don't know, it might simply be low position and exit position, for example, that is stored in this little array. So let's subtract those and see what we get. So 6080 minus 65.6 is 42. That's definitely, well, no, so it's definitely not, I mean, there is some information there, but it's definitely not what I thought it was. Wait, where did we jump? Yeah, we're here, right? Yeah, 65.6. If it's a bonus level, we don't jump and we do use this. Okay, so 65.6 is from this position, and the maximum it can go is 60.80. Okay, that's just these three lines here, because 60.80 is here. Okay, so let's see what it reads, right? So we're loading F8 then into the accumulator, which is what we're doing here. Right, F8. We're loading A into C. We're making a copy. Okay, we're incrementing. So we're going to the next one, which is D5. We're loading, okay, we're loading D5 into the accumulator. We're loading A into H and C into L. D5, F8. Okay, we just swapped them around. We popped AF. Wait, let me double check. The memory location pointed by SP is stored into F, and SP is, right, so by SP, okay, DE39, okay, stored into F, sure, and SP is incremented, okay, fine. The memory location pointed to by SP is stored into A, and SP is incremented, okay, that's a complex one, but fine. So DE39 is also something interesting. I mean, this might be indexing. Let's see what DE39 is, because that's what's, oh, right, we are at the start of this. So 93 is going to get loaded, I guess. Yeah. Okay. It's not a bonus level. Calling something. We're loading one into A and then in D97C. C000. Okay. We're clearing memory. And we're here again, D88A. So I wonder, like, D88A is already set now. I mean, this is the level, right? This cannot be anything else than the level. I think FFs are walls. And we're talking about low position here. Oh no, we're going to write, wait, write. So the value of D88A is 0 though. How are we going to convert that? That should put something into HL, but it's 0. 0402. Oh, is that? Yeah, that's literally 0402 is 0 then. Okay. Yeah, so 0402 is this. And that makes sense, right? Wait, does that? Yeah, because, yeah, of course. What does it convert? Yeah, because all this becomes 0, and we add 2 and 4, which becomes 0204. That does make sense. So that function is for sure correct, but where did it get this though? So D88A, I'm very interested in where that gets set. So I'm going to remove this one, and we are going to see what writes to D88A. And we're going to reset. Okay, it's not reset, which is weird. So let me check whether that gets... Okay, so we're blanking out, I think. D88A. Yeah, so why are we not blanking out this? Is it just 2 bytes, but then the other one didn't blank out though? Weird. So let's see what happens in level 2. Okay, this should change now though, because the position of... So the initialize round is called first. That is so crazy, because so we're loading D88A here. Yeah, oh, well, I mean, I have a condition here, but it's not going to be relevant, right? Because that wasn't the case, I think. So D88A is immediately checked here. So unless this one modifies it, okay, Like it did modify it, but why and how? Unless, so LDIR, like if they need to set a byte, why do they use LDIR though? So let's say LDIR again. Transfers a byte of data from the memory location pointed to by HL. So from HL to DE is transferred. Transfers a byte of data from the memory location pointed to by HL to the memory location pointed to by DE. Then they're both incremented and BC is decremented. So BC is a counter, which is 1, so only 1 byte. Right. But we're copying from HL to DE. Did the rest change too? Like this didn't change though, from D627 to D88B until here. Oh, that's the end. And 6 to, did this change? D627, oh yeah, D627. Yeah, did it change from here? So this is the level perhaps. And then these are the 2 last bytes, or well, no, it's not last, but well, yeah, because that was D88B is the end, right? Oh no, the wait, D88A is loaded into DE and 2 in BC. Oh, it does 2. Okay, 2 iterations because BC is 2 here, right? Wait, did we execute? We didn't execute the LDIR yet. And yet this value is different already. So I'm going to execute the LDIR. This did change. So D628. That's right. So it is. So it started at D626. Is that hard-coded somewhere? I guess not, right? That wouldn't make sense. So I guess we're just, this is copying these 2 bytes in that location. I don't know why they use this instruction for that. And D87B. Well, I can't see what HL is here back in time. So yeah, the source seems to be this. So let's keep an eye on this array. Did I give this guy names or not? No, I said perhaps level 2 data, which is not correct. Wait, did I? Yeah, this is not. This is not correct though. I'm gonna disable these. Let's look at this part of memory when the level starts over. I'm going to play nice and do this from without resetting, I mean. So we started here. So that would be the first byte, I guess. So we're loading current level. That would be a parameter for this function, right? So I'm gonna play this 8288, but that should be 0 now though, because and it is already 0. So I'm gonna execute. So okay, what is HL now? D5FC. T5FC. I mean, this is the first starting position. Are they like in sequence here, or? I don't remember the second level being A588, but we can check. So this is the, yeah, this could be the array of starting positions, perhaps. Yeah, because if you look, wait, this is YX. No, this is Lolo's position, Lolo's index, exit position index. And if you remember, in the first level, the exit was here, and in the second level, Lolo starts here, right? So Lolo exit, Lolo. No. These aren't related. I thought they were going to be on the same X chord, but that's not the case. So okay, let's. I want to see if I change this value, whether Lolo starts. If I change it to 1, which would be the first index, which I assume is the second position here. Wait, let's see if that works. Right. So I'm going to try to put Lolo here in the second index, which would mean I have to put this on 1. And let's reset and see if this gets overwritten, or if it's a hard-coded source. Well, no, because this is RAM, it should be in the ROM, right? Yeah. So this is copied over, and let's see if it does change it again. Well, okay, it should be. Why is that? Wait, let's look at our conversion function. So the y is multiplied, so that's weird though. So the y is the bottom part. Okay, yeah, the y is the bottom part. I needed to put it on 1, 0, I think, to put it here. Does that make sense? I want to end up with this XY position, so it's not an index, so to say, unless, oh yeah, no, do they go top to bottom? So 1, 2, well, how many are there? Well, 1, 2, 3, 4, 5, 6, 7. Wait, crap, I lost my count. It's 11 by 11, I think, right? So if I put it on 12, which is 10, 11, 12 piece A, B, C. Let's see if I put it on. Wait, no, that's 11, 10, 11, 12. Yeah, that would put it here. Perhaps C. Let's see, because it's going to override this, of course. No, I miscalculated. I wonder where he is. Oh, he's down here. I'm not understanding the mapping exactly then. Wait, no, I don't need, okay, no, I don't need to be, I need to work the other way around, right? So this is, if this is 0204, meaning y is 2, there are Is it the bottom of the tile then? I don't know. I don't know the coordinate system that well, so I can't really do that. But why? So this at least is the starting position for sure. Question is, what is A5 and A8? So let's put that. Well, that's going to be exit position, and this is Lolo's position, so A5. So if I do this, does that mean then that in the second level, Lolo gets put in the top ref position as well? I'm have to play it though. So yeah, I'm gonna let this go. I'm gonna put that and see if it gets reset in between levels too. And we're gonna play. I'm gonna disable you and you. Oh, it reset. Is it not happy? Oh, or does it mean anything else, something else, and I changed it and it's confused? It might be though. Yeah, it can't work with that. So this is not level 2. I thought it was like for every like an array for every 100 levels, all the starting positions, but apparently not. So that means that this probably will get changed, which makes sense though. For every time we reload a level. I could have checked that, of course. But yeah, so this might be a copy from the ROM, even though nothing changes in here, but that contains the definition of the level itself. So let's see what happens if I finish this one now. I'm going to block on this one though, because I'm gonna want to change the value. Okay, it hasn't changed yet over here, and down here it is still the same. So let's see if this call changes this data here. It does not. And has it changed here? It already changed here. That's crazy. $82.88. Where is that picking up from? Okay, so that means I have to break on right for the when loading the second level, which is this simply, and I'm going to, well, is it going to remove my things again? Level 1 just, oh great crap. That's not too difficult. Right on D88A. Let's see what it's, I mean, it was going to be here, right? I could have simply looked into this first function here. Are we breaking? Yes, we're breaking on that. So I'm assuming it's going to be in this function that we are going to, well, no, let's play. Right, so now HL is D627. Okay, that's here. Okay, so this is an array. Okay, so the array size, or the record size within the array is from here to here. So this is all level data for the first level. And the second level starts here. Okay. Do we have 100 levels though? That doesn't look like it's enough. Or is it maybe the first 5? Like it could copy the first 5 perhaps? Because maybe this is the start of the next one. Oh no. This one perhaps? I don't know. So I want to be breaking here A4BE, A4BE, because I'm going to go to the end of this level, and I'm probably going to lose the breakpoint again, maybe. Level 2 before exit. I did not lose it. Now let's see what we have now. In HL is D65B. Yeah, so that's this one then. So that's the third level. I mean, it only has space for 5 levels, it seems, though. So the next one would be, I mean, I can calculate the difference, though, the distance. So that would be, where are we? No, let's take the end. It was this one here. So this address, D625 minus D5FC gives us 41 bytes or 29 hex. So we are now at D65B plus D65B is D684. It's weird that then just like there's no spacing, whereas there was spacing here, but that's fine, I guess. So let's see if D685 is the next one, whether we were right in our assumption here. I'm going to continue. I'm going to go to, okay, this happens quite a few times though, that's interesting too. I'm going to go to the end of level 3. No, this one. And let's see if D685 is our next target. D67A. That's very weird. I mean, it's going to be this one, right? Yeah. Why is that distance different though? Did I make a mistake in my calculation here? That's weird. So at least we have level, what level is this? 4, I think. Yeah, 4 we have here. And then 5 is going to be this one. Maybe 6 or the first bonus level perhaps. So let's go to level 5 and check whether it's D682. And that's level Medusa before exits. So we're targeting D682. Correct, D682. And the next one would be probably this one. And then we'll see what happens. Oh yeah, so it's 5 levels and a bonus level. So yeah, so after the bonus level, it will change this data out for the next 5. Okay, so D6CC is the next target. Let's see, end of level 5. Oh, okay. Right, it's, yeah, it's between 5 and 6. So let's see. I mean, I'm assuming it's going to be, oh, no, it should be 00 again, right? Well, no, okay, let's just see. Do I have end of bonus level? Bonus, okay, I don't have end of bonus level, so we have to play it a bit. Or wait until the time goes down. I was gonna save, but of course it immediately stops. Okay, so let's see if this entire chunk of memory changes when I continue now. And apparently it does not. What is our target? 6E5C. Wait, what? 6E5C is a target. That is very weird. Wait, we are looking at, yeah, D88A. So this didn't change, and now we are referencing 6E5C. Which, sure, oh wait, is this the copy function? Is this because that looks like positions and stuff again, right? Does this copy? No, it's the same thing, no. Why would it be referencing that now and not put that information here? Yeah, that's the A0 from down there. I would have expected this to get overwritten though. That's very weird. Do I have the end of 6? I don't think so. I guess I have to play this one too, if I can. Yeah. So I have to get off first the second one, right? So I can't get off here. I have to pick up this bottom one and get back on. Pick this one up. Always a stressful level, even when I was a kid. Get this one. Get back on. And then I can just shoot out the bottom one, and that should be fine. Oops. Okay, and then save this state. Hopefully I don't go in the exit. Nope. Okay, and let's see where we end up now. 6E95. So now we're referencing memory that's like way down there. Very weird. I mean, I guess we'll just have to look where HL is set, right? So we're loading 6D5F8 into HL, calling something. Oh no, we're returning condition C. That's fine. D5F8 is loading a different function. So perhaps it is this one. Okay, let's go back to, for example, this one. Okay, we're not breaking here. And we have to know where we and where we start though. Okay, so let's continue. Where do we enter? Okay, so it's this one. Oh, we're coming straight in this function. And it looks like, so I don't know which level we were loading though. I mean the second level, right? D623 is already put in our HL address here, meaning we are not determining or setting HL in this function. Let's see. So we're loading D87B, that's fine, that's another one. And then D88A. HL is D626. Now, why did that increment? Oh, right. So we're doing the 3 bytes before that as well. Okay. So it's copying the, so D87B, is that correct? D87B. Well, of course, they got copied to a different area. That's fine, but it does three bytes. So it starts here, and then these in this first section here, and then the 2 bytes following that. Yeah. So it's the 5 bytes here are these guys that are relevant. So something sets our HL to D623, determining which stuff we have to load for the positions of Lolo and the exit door. So I'm going to disable this one, and probably it's going to be this one that calls that, right? A824, wait, was it? No, it wasn't this one, so let's escape this one. A4B0. It does start here though. Oh yeah, no, it does. A4B0 is like the little initialization routine, right? So, so it is indeed called here, and we're adding an index onto HL here, adding again to HL, loading the value of HL into A, increasing HL. Okay, getting the current level, that's fine. Are we in a known function? No, we are not. FEDB, FCC1. This looks like an interesting function though. Let's see. It's already here. Weird. It calls this twice. So it's not this far up then. It's fine. Do we have returns here? I didn't see any. Can we go up here? Surely that wasn't a convert function though. I mean, we are initialize around here. Was it this one then? A824 656. Oh, are these the pointers? Wait, we're back where we started, right? Remember these two, depending on bonus level or not? 6D56, let's go back and see what that is. Wait, can I open a different general memory? Aha. Wait. Do not dock. The 5F8 D5, F8. Absolutely. These are the pointers. Yes. Okay, that makes sense. Question is, how many are there? Like 1, 2, well, these are 4, right? 4, 8 per, so there's only 16, 20, 21, 24, 5. Oh, is this because the bonus level? So 6E59. Wait, D5. Oh, no, it's per 5, because there's 5 levels here. We only need 105 over 5, right? Because, so D5, F8, D5, F8 points here, which is the first level, sure. And then the next one points to 6E59, which is what we saw, right, for the level 6. So this is level 1, 6, and then level 11, 16. Wait, so how many do we have? 1, 2, 3, 4 per, that's 8 per line, 16, 20, 21, 22, well, 25. Wait, well, yeah, that makes sense, right? 25 pointers times 5 levels is 100 levels, right? So something, we're doing something else for the 5 final levels, and the bonus levels are separate. Well, the bonus level have a different pointer, right? So yeah, these are simply pointers to level data or whatever. I mean, I wonder what else is in here though, because we are only using the first 5 bytes, the 2 byte 4 and 5 being Lolo's position and the exit position. I wonder what else, what this all means though. What else information there is? But yeah, so 65.6, which is this one here, points to these are pointers to pointer, well, I'm gonna make it plural, pointers to level data, and then pointers to bonus level data, and it's per 5. Well, I'm gonna start with the first one. So this points to an array of, well, this is, okay, an array of pointers to level data containing Lolo start pause and exit pause. The level data is per 5 levels, so there are 25 entries in this array. Same for bonus levels, and I will count 60, 80, wait, 60, okay, I closed the window, I think. No, I didn't. 60, 80, starts here. Okay, so no, wait, I'm counting too many. So we started at 65.6. So we have 4, 8, 12, 16, 20, 21. Because this one starts at 60, 80 though. And we have 1, 2, 3, 4. We only have 4 bonus levels. No, right? Let's look at the levels. stages. Right, so let's look at bonus stages. Very brief. Bonus route 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rounds. Okay, so there are 10 bonus rounds. 1, 2, 3, 4. 4 pointers of 5 levels. 4 times 5 is 20. Why so many though? Unless there's fewer in this pointer, so let's look at what that contains, which is 8955. That's also a low number. Well, no, that's fine. 8955. I mean, I can't really see how large they are because we only know about the 3 first bytes. I can't really count here. Like this is 1, this is 1. Like 1, 2, 3. I mean, if it is actually 3, then that could make sense. 3 times 5 is 15, and we have 10. I don't know. This might vary because it's a set of pointers now. So yeah, D5 F8 contains our first set, and I assume it's only 5. Like 1, 2, 3. And then this is shorter, so why would that? Doesn't really make sense. Unless it's compressed, unless it's like we know the length of each one, that's also possible. So with 1, 2, 3, 4, 5, 6 perhaps. I mean, it could contain 6 levels though. Because like, it looks like there's a 6th one here. Although no, we checked that. After 5 levels, it went somewhere else. Okay, so these are pointers to level data and bonus level data. Okay, so that is indeed now correct. Okay, so this one and this one. And I mean, we can document the first one, D5F8. Round 1 map data pointer, I guess, because we don't know what it points to yet. And then we have this one, which is D5FC. Okay, that didn't copy. I did. Oops. And that's round 1 mob data, Lolo start index, and D is exit door index, right? And I mean, I can do the other ones too, but yeah, we'll see. I mean, I can do the pointer to the second one though. Which was this one here. and oh, I can't remember the, oh, no, it was this one, 623, and then 6 and 7. Right. These are then copied over down here. I don't know what to name that though, like I have to keep coming up with names here. Because it's, why would it be copied like temporarily to this position when you could just reference the actual data, right, which is right here, and apparently doesn't change ever. But fine, let's give it a name. It's D88A. And that would be current, I guess, current map data. No, it's not going to be exit door, it's going to be Lola position, Lola start index, and then B is the exit door. I mean, I guess that's fine. So yeah, now these have a name too, and it's current map, because that's where we load the current map data. Right, and now these become visible here too, that's fine. Yeah, okay, we have our two pointers here. Okay, we have another, no, I thought it was data, it is not. Let's see. Right, this is a clearing, okay. I'm going to return to the initialize round function because we're right here at the moment. Did we determine what A24 did exactly though? Right, so it loads these pointers, it loads, I'm going to go in there again, wait. So let's reload, let's stop here. I don't know what this one was. Oh yeah, this was the clearing, I guess. Yeah, this clears, it copies into 2 bytes into the start index. Makes sense. Oh, and we didn't know what D87B was. So we have to see what these values represent though. D87B is this one, and these 3 bytes are also level related, also copied over from here. So I'm gonna try put some values in there because they all seem to be 0 for some reason in most of the levels here, at least in the first 5 levels. So let's put some data in there and see what it does. So I'm gonna disable this one. No, I'm gonna wait. I'm gonna before it gets copied. Let's put a breakpoint there. Let's load where we just are before the exit, and we exit the level, and let's put some, it's going to be this one. We're going to put some garbage data in that. I mean, it's already copied, right? So let's just go to the target, 87B. Let's put some values in and see if it changes something. It might crash, I don't know. Oh yeah, these are power-ups. These are the power-ups we get with the level, right? And the first 5 levels don't have power-ups, of course. I don't know what the first level is that has a power-up, but clearly these are the power-ups. Yeah, so I'm gonna see if I can change the values though to something more sane than FF. I don't know why it chose blocks for FF, but what was it? B, yes. So I'm gonna do 1, 2, 3, which I assume is all the options, like the arrow, the bridge, and the block. And continue. Oh no. So I mean, I could find a level, of course, that has a power-up. I don't know by heart which one would have a power. Does it say in the level? Okay, round 8 apparently has an arrow power. Okay, round 8. I think I went up to round 6. Yeah. I mean, I'm not at round 8 yet, but I guess I can add these. I'd have to play, but I don't know whether I can, because I do suck at this. Oh yeah, this is an easy one, I think. This would be, I'm going to save this as level 7 start. I think, what did we have to do? Can't remember exactly how to play this one. I think we just have to pick it up, right? As in the one next to the skull, and then yeah, that should be fine. And let's see, level 8 then should have some values in those 3 memory locations. Oh wait, I need to, because I'm blocking this one in. Oh yeah, I need to pick up the one with bullets, which is this one, and then shoot the skull. But I'll block myself in. That doesn't matter then. Oh yeah, no, I know. I have to, because I will go into the exit. Level 7 before exit. Create, and that's just in time. And then level 8 start. Yeah, so we have a power up here, and indeed we have 88 in our first power up slot. Let's just save this one. Level 8 start. I can't remember the IDs of the power-ups though, like 88, that sounds a bit high. Unless it is... No, I never noted down what the values were of the power-ups. 88 looks like either a sprite index or a tile index. I mean, it's not a sprite, right? No, they are not here. The arrows. So let's look at the tiles and see what 88 is. 88 hex is 136. No, the arrows are very low. 136 is going to be... Yeah, no, it's definitely not a tile ID. But nevertheless, we can document this. Hi MDS Ubuntu, thanks for the follow. We can document them at least. So D8, what was it, 7B. So D8, 7B seems to be current map data power up 1. And then 2 and 3, and then these values are 88 equals arrow power up, or power, I guess it's called, but that's fine. That's C. Oops. Okay. C and D. Let's refresh here. Okay, so we have these 3 known now as well. Meaning, for example, if we go to our first one, so we have to go to the pointer data of our levels. If we go for the first 5 levels, and oh, they are picked up from elsewhere because the zeros aren't here. Wait, no. Oh, no, it's no. It's the information is in D5, F8. Yeah, it's these 3. So if you put 88 here, that means for the first level we will get a power up, an arrow power up, but it's going to reset this value though. I don't know if it'll keep it. I think it might. So yeah, or let's just give ourselves 3 arrows. Let's see if that works. Yeah, absolutely. What we also need though is the amounts. So you can put amounts there, the amount of heart framers you have to pick up to activate the power up should be stored somewhere else too. I don't know yet where that is, but that might be one of the other values here. Let's see. So yeah, let's change this name to round 1. Yeah, this is going to be power up 1, 2 and 3 being 9 and 10. And then no, reload here. Yeah, so these have to be changed to, well, I'm just going to change this one, 4 and 5. I've only done 2 levels, but that should be fine. Okay, so we know what these are now as well. Right, so what is the value? That's should it be 1? Yeah, no, it's not. So it's when the power up is to be activated, it flickers, or the heart appears, and that hasn't happened yet. So the information that says how many heart framers you have to pick up before the power is activated is wrong in this case. Unless it's every one of them, which we will know in a second here. So yeah, that information is definitely not written. No, it's not. It might be this one though. It might be the 4th byte, because we only need to store, like, I think the max is 5. So we only need to store like maximum 15, and we can do that with bit manipulation, I guess, to see which one of the 3 power-ups belongs to which bit, right? But we knew that level 8 had a power-up. So I can go look at level 8, right? So I need to go look at the 2nd pointer, because it's per 5. So we need to go look at this address. So this is for the first 5 levels, and this is for the next one, the next 5. So 6E59 is our level data. 59. Okay, so this is the first. Oh yeah, that's the reason why I didn't see all these 3 zeros. So this is level 6. I need to find level 7, but I don't know the length. So that was 8.8. It's probably this 8.8 here. Although it should be 8800000, right? Because we have 2 spaces for, like, we have 3 power-ups, the locations. I mean, this is suspicious, but Actually, we can figure it out if we do a read pointer on this one. Yeah, let's do that. So let's put this in as a watch point at a read, and we'll see if it's in the correct position. Okay, let's go to, oh, it's going to remove my watch point, of course. That sucks. Level 8 starts. No, we have to do this one, right? And of course, I can't be this quick because I have to reinstate the watch point, and this thing is gonna kill me. Right, I can't push this to the right. Crap. It sucks that it removes the watch points every time you open a new. I mean, I can replay level 7 though. That's. I mean, I guess I'll have to, but level 7. No, level 7 start. Let's add this one again for reading, and do this entire thing again. That's correct, right? 6E66. That's the one I assume it is. Although it doesn't really make sense because it should be 880000, right? If my theory is correct here. Okay, so we need to get the bullets here. I mean, I could force that. I could have forced that better by just, yeah, no, I should have done it differently by giving myself some more ammo. Let's see if we break. No, so it's not this 88. That sucks. I mean, I looked at the correct pointer, 6E59. 6E5, I mean, it's right here, right? So this is the first pointer, this is the second pointer. 6E59 is the address, 6E59, that's the first one. And I put one on 6E66. Wait, did I put one on 6E66? Yeah, this one. 6E59, sure. And then 6E66. Yeah, that was my assumption. Wait, the 88 can be a manipulated number though. Wait, so there might have been some manipulation going on. Do I have this thing again? Yeah, it's this, right? I just need to break here. Because that copies the 3 bytes of the power-ups. Well, let's put it here. Right, so that should break us. If I go, don't die. Yeah, that breaks us here, and HL is 6ED7. ED, okay, it's way down here, and here, yeah, okay. Yeah, it's this 88, so there was way more information here, apparently. So what was I looking at? 6E59 over here. 6E59. Okay, so that was the start, and it is here. This is level 6. Oh, and we're in level 8. Right, makes sense. Yeah, so this is the first one, this is the second one, and then we are here in 6ED7. Yeah. And this is 7A, but there, okay, so it's just 3 zeros, and then the fourth is 7A. But we only copy 3 bytes from here and 2 bytes from here. So it's just the amount of power-ups and the low position and the exit door position. Meaning that if you go back to our map data, our actual, I don't know where that was, the amount of hard framers you need to pick up to activate the power up is not stored directly in these 5 bytes. Right, that's not, yeah. I need to give this a name too though, because this is a, I think it starts here, yeah, 84A8 is like load map data, or yeah, load map data into current map or something like that. Yeah. So let's do A4. I don't think I have something in 84. No. That's quite high up for a function in the ROM. No, this is data. Okay, no, that's 4. So we're definitely below that. 4, 4, 4. Still 4, 5. Oh, no, we're... Okay, my mistake. We're quite low down. I'm going to put it... Okay, I didn't sort these bottom ones yet. Okay, this comes quite low though, indeed. So we're looking at A4B6, and this looks to be load map data into current map data, and this no, I'm gonna put it above. This loads at least power up and low spawn exit spawn position from the array of pointers, which is called this. Yeah, let's give this a name indeed, and then we have this function in initialize round with a name too. No, we do not. Was this called in A24 then? I don't remember where that got called though. Huh. But I mean, we can look at that one in detail, in more detail later. So it's A824 that gets called. Okay. Not super important. I mean, it must happen before, like between the initialization, or did it happen before the initialize round function? That's interesting to know too, of course. And it's being called multiple times as well, though. So let's go back to level 1. No, I want to do level 2. So level 1 at the end. So what gets called first? Okay, initialize round does get called first. And I wonder if I go over 824, will it stop? Yes, it does. So 824 does indeed call this one deeper down. So yeah, it must initialize more stuff though. So let's see what this one does as well, right? So we're doing the loading. Wait, am I correct here? No, I'm not. Oh no, my breakpoint. No, my breakpoint is wrong. The function starts up here. Yeah. It's the wrong address here. A4, A8 is the function. Is that why I didn't see the name in the initialize function? No, still not A824. Okay, again, load exit 1. Okay, initialize round first, and then we call, I mean, I'm gonna go in now though. We go into A824 and see where we end up. So yeah, we're checking the current bonus level. Okay, yeah. So this gets the base pointers, right? Whether we're in a bonus level or not, it searches the correct pointer. So it's going to go for pointers to level data, sure, because we're not in a bonus level. And we're loading the current level, decrementing because we're indexing, so we are 0 based instead of 1 based. We're comparing to a 5 for some reason. They do contain multiples of 5 though. So we might have to do some math there, but fine. So we're loading the value of HL. Oh no, okay, that's not really relevant now. I want to see where it breaks though in the other function. Okay. Okay, we're looping twice. We're still not breaking, perhaps in this one. No, so we return now. And we still haven't broken in our load map data though. That's very weird. Because last time we did break in that. Wait, what are we doing here? Because we're loading current map data power up and we're clearing that RE. D87B. So we have our power ups. I mean, they're all 0 though. I'm going to put some values in there so we see if we get overwritten here. So yeah, D235 is the source. Wait, but that's hard-coded D235 though. No. Oh, these three. Why would that be? Because now we're copying these three into our working area here. This one. So yeah, this is going to put 3 zeros in there. Now, no. Oh, does it copy them there? Is it the other way around? Yes, it is. Okay. So, okay, it has a third location to store these stupid power-ups, IDs. Because these are indeed the counts, right? So power-up 1 needs one more hard framer to activate it. That's a bool indicating it's flickering. The hard is flickering. And yeah, here are the counts. And I think amount of power-ups activated. I think we had a count somewhere as well, like how many we need to pick up. But why are they again copied here though? At least we know these three are the power-up IDs though of the current map. But I mean, how I'm gonna name that? Like, this was already my current. No, this one was already my current map data power-up. Like it literally copies this. That seems to be a bit inefficient, unless, well, no, I was gonna say unless, because this will change, right? If you pick them up, it'll probably like be removed. So let's see if we can put power-ups in there. Okay, we're at the start of initialize round. Yeah, so we do have them, and yeah, the reason when I tried before was picking up hard framers and see when they would start flickering. That didn't work because I don't think they were in here, perhaps, were they? Let's see what happens if I pick up the first one. Yeah, no, that doesn't change anything. I don't know why. Not sure, but I mean, we can see this in level 8 too, right? If we go to level 8 or 7 before exit, we exit. Let's see what gets copied into here. It should be 88. Yeah, we can see this here, even if we just jump there. It's because it was right here, right? It's this one here. Yeah, this one now. Yeah, so we have our 88 here too. But why? No clue. I mean, I can give it the same name or like a similar name, I guess. current map data, current map data power up. Yeah, like this stuff is the same as 235. And of course they're not next to each other, so I'm gonna have to put them higher up. 235 is this one. I mean, it's 567. I mean, what else am I gonna name it, right? So yeah, this is now power up 1, 2, and 3. What's weird though is that these values become, this is 80 though. And I think instead of needs one more hard framer to activate, this makes it look like it's a Boolean, and it isn't. I think this is that little number in construction mode that says how many hard framers are remaining to activate. So I'll pick one up and see what the 80 changes to. Oh, it doesn't. Oh, but it's not activated either. Nor is it now. Okay, how many do I have to pick up here? 4. I guess it's 6. No, okay. Okay, it's at the very end, I think, when the skulls activate, that you have to that you can change an arrow. Oh no, okay. Yeah, so now it's right. It's shifting between 1 and 9. I remember. Huh. And was that a sprite? Wait, let me go look. Needs one more. Yeah. So 1 through 9 is blinking hard, and 10 is a solid hard. But like, I mean, I can change this to this, and it still keeps working, right? And it wasn't a tile index, because if we look at 81, that's 129. These are sprites, right? Because wait, they're not. 129. Yeah, that's odd. So that's definitely not a sprite. And the tile 129 could be the hard. No, that's 44 and 45, and 129 is, yeah, that's a snaky head. So yeah, that's definitely not the case. Now it's 10. Okay, quickly. No, quickly. And yeah, it's weird. So I don't have the exact oh wait, now it didn't even break onload map data into current map data. That's also interesting, because why it did not break there. Very interesting. Right, so now we have 2 power-ups. Oh, and now we have 40 here. Yeah, this value, I think the 4 might imply how many we have to pick up or something. Yeah, it has a meaning though, because it used to be 80 and stuff, and that was all of them perhaps, or were there 8 in that level? Wait, let me first. Did I save this state? No, I did not. Level 9 start. and I did 8, right? 8 before exit. Okay, so this one has, so this one says 4 in the first part here, right? So does that mean you have to pick up 4 until the first power-up is available? Let's see. Oh no, it's 2. No. Well, I mean, it's 3, right? Because I have to pick up the third. Or no, is it active? No, it is active. Okay, sure. No, I have to do that up there, I think. I can't remember how to play this level. I think I have to put it up here. Yeah, so it's 41, 49 flickering now. Oh no, I do have to, yeah, of course I have to pick up another one. Yeah, so let's give myself more ammo here, because I wasted mine. Yeah, I have to pick up Snaky, I think. No, let's pick up the skulls. Okay, so now it's active, and it is, where are we? Yeah, 42. Oh, and now the second one becomes 40. Yeah, so the description is definitely wrong for this variable. This is like completion state, like, and 2 is also solid hard. Yeah, I'm not sure about the contents of these values, but it's definitely not. Needs one more hard framer to activate. Well, I mean, technically yes, but I think this is simply state. Yeah, I think that says it better. So you have the power up and you have its state. That makes more sense. Yeah, because now this one is the active one, I guess. I'll have to experiment with that. Fine. So initialize round. Let's look at that again. We're breaking in initialize round. Okay. We were here, so let's move there. Okay, we copied our power-up data. We're loading the start index or the Lolo start index. Okay, we're converting that to a position, putting that in our Lolo position, loading 5 for direction facing, which is front. I think I don't have that. Well, 5 is down, yeah, of course, facing the camera, so to say. We're checking whether we have a bonus level, which we do not. And then we load the exit door index, because bonus levels don't have exit doors. That would be skipped then, right? 675F. 675. Oh, yeah. It skips these things here. Okay, so it places the tile for the exit door. It's strange that it doesn't do that for Lolo though. Oh no, obviously it doesn't, because Lolo is a sprite and the exit door is a tile, or 4 tiles. Right, makes sense. Okay, exit door still. The 8 is also an interesting thing to pass. Well, oh, is it tile ID 8? That would be top left or bottom left or something of the exit door. Yeah. That's 8 is top left of the exit door. Yeah. Okay. Then 0402 is suspicious because it is the top left position. So we might be looping the entire map or something. Oh, and we're putting that into D269. Also interesting, because it's an unknown. And that's this one. And we are hard-coded loading in 0402. Right? Yeah, because we're putting this. Or is it what do D269 points to? Wait, let's see. Yeah, no, we're putting 0204 in here as a hard-coded value though. Why? And then we're putting D97D into HL hard-coded, so that's an address to D97D. This one. Okay, are we gonna write something? Yeah, maybe. So 79 in B, the value of HL, which is 0 now. Okay, so that might be an interesting value to look at, because we're going to call a function based on that, but seeing as it's 0, it's probably not going to do anything. I mean, I can put a value in there and see if it changes something. But yeah, let's keep an eye on this one. Doesn't change anything visibly or immediately. But what we can do is we can look if we have another level where that value is set. Not in level 1, neither in level 2, I think, and level 3, 4, neither, 5, nope, 7, also no, nope, and 9 either. Okay, never mind. It's hard to figure out what it is if it doesn't change, of course. So where are we? Here, right? D97D here. Okay, we're calling a function here, so let's see what this does. If we can figure it out, 67E8 does not break during the level. That's good, because it's level initialization, of course. So let's go to level 2. Okay, first breakpoint, second breakpoint, 67E8. We are past D97D, which is the one we're looking at. Okay, what do we do here? Loading A into C. So we have a first parameter being 0, which is probably the value. I can't remember. We're ANDing it with FC, sure, comparing to 4 and calling conditionally, which we don't do. C into A, that's fine, ANDing it. Okay, so FC and F0 is being ANDed, and then comparing to 10 or 16 at least. Again, conditional call. Now comparing to E8, is that the number we recognize? 232. This was the case. Okay. Weird. I'm gonna do that again. Oh, it's called again within the same initialization though. Wait, and where did we end up? That's weird. Unless we are, okay, 676A is this one. Okay, we're looping this how many times? Wait, so let me break on this one and disable this one. No. 67E8. We're doing this very many times. 74, right? So we're probably looping over the entire map here. We are at 116. So if we look, there are 11 by 11 positions, and that's 79. So did we start? Yeah, 79 here. So we're looping every tile, calling 2 functions over every tile. Thank you, Beatrice Bird, for the follow. Sorry, I don't have any notifications yet, so I have to look from time to time, and I do miss them sometimes. I don't know if you're still here. Yes, you are. Thanks for the follow, though. So yeah, we're looping every tile here because there's a hex 79 amount of tiles, which is 121. Now, question is, what do these functions do, right? So I'm assuming that HL, well, no. Okay, let's see what's in HL the first time we call this function. So let's restart. No, I want you to not break. Now you can break when we load. Well, no, it's gonna break again, of course. No, I know, we have to do it here. Okay. Okay, so we're down here, right? Yeah. So yeah, 79 is our counter, which is the amount of tiles 11 by 11 that we have in the map. And then HL is the value of HL is loaded into A, which was what we were looking at, which is 0. So it is related here in our loop. Okay. That value doesn't change, at least for the first function, or it might, or in the loop it might be affected. Yeah, so let's load that first. Okay, so we have 0 in AF, and now we will see what we get. Do we have a pointer to anything relating to the map, though? Okay, we're pushing some stuff. The A is what comes into the function, which is now 0. That's this value here. And we're doing checks on that. But it's all going to be 0 or like, it's not going to compare, right? Okay, and we return for this. Then next iteration, well, we're doing a different function now. I do want to know whether the accumulator changes the next iteration. It does. Well, oh, it jumps to this one. Okay, so HL has changed now, D97F. So it jumped by 2. So this is an array as again for one or 2 bytes per square we have, like per position. Would that make sense, seeing as there are 2 tiles per, so we have 11 by 11, but every block consists of 4 tiles, 2 horizontally and 2 vertically. So these two bytes might mean one thing per tile, and we're treating them as blocks. Okay, so let's see what's in 690F, because we don't know exactly what this first one does. Let's disable 67E8. Oops, I shouldn't have done that. Wait, where are we? No, we are here still. Yeah, okay, so we're now at OC. Well, what's weird though is, did I make a mistake here? D981 is this one, right? And that's 0 again. Okay. Okay, so we are looping through the array, but they're all zeros, of course. So I have to find something where this isn't 0. It might be, because we're doing water after this, it might be water related though. Even though I checked the first 9 levels or 8 levels and nothing changed here, I think. Okay, so let's skip over this one and go into this one. Okay, we're loading D269. That's also an unknown, which is higher up. Let's go there. Okay, we're increasing HL twice, meaning, well, that's for the next loop, the next loop iteration, I assume, because we don't see any internal loops here, but we are referencing D269 though, and we are writing something in there. What is that? Okay, that's these guys here. I wonder what that's going to be. So IY is in play too, which we are incrementing by 2. IY is db65. Let me put that in a different window here. db65. This looks like map data again, or like something related to tile IDs. Right, this looks interesting. No, can you not go off screen? You cannot. Okay, small then. Okay, this docking does not work 100% though. Okay, is it stuck? It's stuck. Can I close this one? No, let's open another one. Crap. Okay, I have to reset, I guess. My window's stuck. Probably didn't save my breakpoints. Of course it isn't. It didn't. Because why would it? The window's still here though. Never mind. We were in our initialization thing, right? 67D1. Okay, let's put the breakpoint here again. We were actually in this little loop. Where were we? Here, these guys. This one. Level 1 before exit. We exit and break, and we go into this one again. Okay, so yeah, this was referencing, so in IY was referencing data, right? db61. And also D269, which was this one here. O204 is the top left position here. That's the address. Oh yeah, and I do remember our initialization function writing O204 hard-coded to this position, I think. Yeah, wait, let me look that up. So I'm certain. No, I have to go here. Initializer, was it here? I can't remember, maybe it was in this one, but I do remember, yeah, no, here. O204, yeah. O204 is, the value is loaded into HL, and then HL is written to D269, which happens to be this one. So these are the XY coordinates, or YX, I guess, of this first block. Very interesting. Yeah. So we're loading 0, and which corresponds to position 0 in the index wise. Okay. We're loading H, which would be the Y position of that coordinate. We're adding 4. Okay, now we're getting Okay, so we have 8. We're loading A into H. So we added 4 and compare it to 30. This might be end of line detection too, though. Like if we have to skip, no, I wanted to do this. 30 is 3 times 16, of course, which is, what is it, 48? Yeah, 48. 48, is that special? We have 11, 22, 44. No, 48 is not special in that regard. Let's see. So we're comparing to 30 hex and doing a conditional jump, which we take, and then we write HL into D269. It might be working on the map data that we can't visualize yet, though. Unless I know the level we are loading is the one with the 2 skulls, right? So that one has nothing in position in the first position here. So maybe that's why it's skipping. But yeah, so we're loading now 0804 into well, at least 08 into 269 here. Or 0208, yes. That's YX though. So yeah, we skipped to the next one here, I assume. Yeah. And we're out of this function. So we didn't do anything, and I assume it is because there is nothing in that level there. So if we go look here, and we go round 2. No, I want round 2. Yeah, so this is, there are 2 skulls here. We start here, and these 2 first things have nothing in them. Maybe it's related. And the third one we'll encounter is a hard framer in position 3. So let's see if that's the same thing. Yeah, so we exit this function and we will go through the loop. We increment HL, or no, we load HL, which has been incremented. We don't know what this one does, but we're going back into this one, and I'm assuming it's going to do the same thing where we skip over most of it. Right, so we load D269 again. Yeah, that's our current position, which we will be updating. We're adding 4, meaning OC, right? That's 12, right? And comparing it with the end of the thing, I guess. So wait, it does make sense, I think, does it? So 30 is 48 hex, and we're going by 2, so 44. Yeah, it does make sense. So we have 11 tiles horizontally. Hi, Albert. So yeah, we have 11 blocks consisting horizontally of 2 tiles, so there's 22. We are looping the entire row, and our end condition is 22 plus 4, because we're adding 4 here, and we're checking, is it 48, meaning 11 times 2 is 20. Wait, no, 11 times 2, of course, it does 4 tiles per block, right? That's why. So that makes it 44. So 11 times 4, and then it adds 4, checks whether it's 30, and then oh, Alberta, sorry, I misread, my mistake. Yeah, of course. Yeah, so the end condition is 48, right? And that's when it exits. So 6935 is probably at the end. 6935, yeah, that's right at the end. But we're not doing that, right? Or is it perhaps doing something only at the end? Perhaps, yeah, perhaps going to the next row, right? Yes. Okay, so that function only does something when we are at the end of the row, meaning probably like incrementing the y. Would it do that? Wait, let's see. So we're adding 4 to the X position, comparing whether it's at the end, jump if it's not, which we have been doing, and then we're loading 16 X, which would be 22. Interesting number. Right, and we're adding that to the pointer. This function probably just moves the Y position down. Yeah, this is going to increment this to either 6 or 6, I think. I am from Belgium in Europe, which you might hear from my accent. Well, what you would hear is I'm not from America, right? My accent isn't the best, but yeah, I'm from Belgium. Yeah, so OC would be, so we're in the 3rd position, right? No, we're in the 2nd position. No, we're in the 3rd. Because, yeah, OC is, of course, 12, meaning 4, 8, 12, we're in the 3rd position. So yeah, all I think this does is move us down, Y position-wise. Because do we write this somewhere? I guess this is just the, what does this do? This is, yeah, so at the end, it writes indeed HL back to this position. So this is actually, whilst loading the level, the current position tracker. Yeah, I think so. Well, this isn't really open source. Well, I will open source my findings here, like the symbol data will be open source, but it's not yet. But this project only started like last week or something. I don't know, the VODs are not all saved because I'm not even affiliate yet. So I don't know the exact date, but it's like a couple days we've been looking at this. But I did find a couple things already. I mean, we still have lots to do, but we did find some stuff already. But yeah, not that long, not that long. So yeah, this is an update current position function. Let's run back here. This might be an, oh, how long? Well, that's a bit of a difficult question because I don't know if I will be able to do everything, right? If I to like figure out what everything does, that's going to be quite a bit of work. But the goal might be to, I mean, the reason why I'm reverse engineering this is to remake the game, and I want to make it or remake it like in JavaScript or whatever, and remake it as like close to the original as I can. And for that, I need to know how the AI exactly works. I mean, you can deduce that from looking at it, but then you're not 100% certain, right? So I do want to like figure out everything, how it works internally, and then re-implement it as close as possible. And I don't need to reverse engineer like everything in the entire ROM. Well, sure, you can, of course. That would be much appreciated. But yeah, you don't need everything in the ROM reverse engineered to re-implement it, but you need a big part of it. Yeah. I mean, it's also for fun though. Like I do enjoy doing this, so I do enjoy it. Yeah. 690F. Let's see. I'm gonna have a hard time naming this though, because this is like an internal function, probably only used within this initialization function. So 69F is, yeah, it was this one, right? 69F would be a function that updates the working coordinates during level initialization. Big name, but okay, that's this one. Let's reload our symbols here. Oh, that's called multiple times even. Okay, that's good. Oh, right, and I think we are inserting our enemies here because we see references to our Snaky, Medusa, Skull, and Alma positions. And we're calling functions. Yeah. So we're putting stuff in the level, right? I'm going to name this the working position during level initialization as well, because, or Y and X, I mean. D269. That would be level initialization working. Thanks for the follow, Alberta. Working pos Y and X. I mean, I don't know if it's only used for level initialization, of course. I mean, we could figure it out by seeing whether, if the level has initialized completely, whether we are at the end here and that never changes again. If it's like the bottom right tile or a position. Okay, so these we have figured out as well. And now these two, or this function, this one references the same sort of text, I guess. Designing what exactly? I do have some other open source stuff, but I'm still like building on that. I want to do some more of that stuff. But what do you mean, like user interface designing and stuff, or programming as well? Okay, let's look at this one again. 6.7. Oh, what's interesting is there are two different functions. So we have a tight loop here as well, right? Where we're updating, but the functions being called are different. Okay, so we'll do away with this one and go into this one, 6.7. Okay, I already forgot what it was. 6.7E8. But let's reset to, well, no, I can keep this and just load a new state. Ah, right, I see. And you do that for open source projects too, or? Okay, I have to continue and reload the level. That's cool. Okay, so we are at position 0. We are pointing to 0204. Makes sense. Now let's look again, right? Oh yeah, we were comparing stuff. I did mention this already, right? This was end of row, right? because we're only doing something. So let's see where it escapes. You design logos and stuff. That's cool. I don't have the artistic capabilities to design. I mean, I can't draw a straight line. Yeah, sure, you can share. I will take a look at it for sure. I don't know if you can post links though. I don't know, because like I said, I'm not an affiliate. I don't know if I can allow that or not, but you can try for sure. Or if it's on your profile, I will take a look after the stream. I will definitely take a look. Is it yes, it is my name. I don't have Discord on this machine yet. It is my name here, but I don't know the number. But yeah, I'll contact you after the stream or tomorrow or something for sure. Yeah, so let's see where it drops out. We're comparing with 4 though. Oh no, this was not. Was this dropping out? Sure. Yeah, you can do that. Compared with 16. Oh, and the E8 was the one we were looking at, I guess. E8. No, that was 232. So 232. How much is so we have 44 times 11 is 484. No, that's 484 over 2. Oh no, I'm in X, crap. So 11 times 2 times 2, that's the amount of tiles on one row, times 11 rows is 484. That's what we saw, right? E8. No, that's 1E4. Okay, I'll check it out. I will send you a friend request on Discord after the stream. 484 is the amount of tiles in a level, which is 1E4, so it's not that. Okay. Okay. So it triggers here, right? This is the thing that triggers. No, it is not. But I am a programmer, though. I mean, I do. I'm a self-employed programmer, so this is more fun stuff. But yeah. D1C9 is what we are loading. Yeah, that's this one here. Right. So we're doing something with D1C9, but only loading. No, we're incrementing. Okay. So this might keep track of rows. So I'm gonna see whether it breaks here once we processed an entire row, perhaps. So let's see, where are we? Okay, so that's our initial one. That's gonna help. That's going to happen for every tile. No, so it doesn't break there. Maybe it has something to do with water. Let's look at the water level, right? Because water is always special as it has the directions, right? I need another one. Yeah, this one, level 6. Wait, no, I need to do 5 before exits. So it actually loads. Oh, crap. Did I have a state for... No, I need a bonus end one. Just going in the time it down. I mean, it's not that hard to talk to programmers though, but yeah. It is a completely different field of work, of course. Like, okay, 5, 4, 3, 2, create. Okay, now we're at the end here. Let's see if we well, I mean, it's fine. You can ask me any question you want. It's fine though. Okay, we didn't break there, so it's nothing to do with water. That's good to know as well. It is something to do with D1, C9 and CA though. D1, these guys here. Yeah, these two. I am going to put a breakpoint on that though, because I want to know, although like, is it a type of enemy? Let me go through all the different levels. Okay, it's nothing goal related. Nothing Medusa related. Maybe Alma. Nope. Weird. Okay, let's not focus on this one too much then. Let's go back to initialize round. So we don't know exactly what this one does. Okay, where were we? Well, sure. I mean, I have to get used to it too, of course. Like that's how it is. I mean, but yeah, I don't feel bad asking questions. That's fine. Okay, so we did the first one here. Then level initialization working position Y. Okay, so that's after this little loop, right? So let's stop here and see where we are. Okay, first breakpoint, second breakpoint. So we did something with a level, but we can't see it yet, which is unfortunate. Okay, so right, so we're after our little loop here, the tight loop. That was the first one, right? I didn't skip one. Yeah, I think so, because that's the start. And then, yeah, and the second loop was down here. Okay, so we did stuff, and we are reinitializing this to 0402. Because we did end up at 2E04 or 042E, which is weird why we only... Oh no, it's going to be, I think it's a tile underneath here, because we iterate over all the blocks, and at the end we iterated the next, but then we stopped. Because it's strange to me that the X position is also 4, which is at the start of the row. That doesn't really make sense, only if you account for 2E being one more Y position. So what is 2E? 46 over 2, I guess, which is 23. Wait, yeah, that makes sense, right? So 2E is 46, is of course 23, and there are 22. Yeah, that does make sense. So we are at this position here, which we are now resetting, meaning that this position here is indeed our our working position during level initialization. It's just like a variable, which we are now resetting to 0204. So we're starting over. Yes. And now we're doing something with water, apparently. db61. Let's see what db61 is. Again, this map. I wonder if that's, I mean, that's hard-coded, right? And then we use our water flow direction array. So we're probably doing something water-related. And 79, was that the same break? Yeah, it's the same break as here. So that's the top, the end position, the amount of blocks. And we load HL value into A. Okay. And we're calling again, now we're calling a different function though. So let's see if this looks different. Ooh. It's weird to be doing this per block if we're talking about amount of hard framers left. So let's see where we end up. We skip that, okay. We're skipping amount of hard framers left. That's weird though. Why would that be? We're skipping that as well. Are we counting here? Yeah. What we're doing here is we are initializing all these values. So we're counting pretty much. Amount of hard framers left has to be initialized to the amount of hard framers in the level at level initialization. And the amount of snakies have to be counted, the amount of almas have to be counted. So it's going to, and the skulls and the medusas and stuff, and the goals. Yeah, this just counts all the enemies in the level. And these, because these have value, these have memory locations, right? A1. Yeah, so these values get set, like amount of almas in the level. Yeah. These all get set in this function. Count enemies and hard framers. This is what this function does. So let's go back and see where this was. Yeah, not this one. Wait, no, not this one, but this one. So 680F, right? 680F. Yeah, that was the start. Yeah, 680F. .680F. Okay, I'm in the wrong position. That is 60 here. So this is assign hard framer and mob counts during level initialization. Okay, that was an easy one to recognize. Do we have an unset variable or a variable that we don't know yet? That would be interesting too. So it has to compare the ID though, and I don't see any hard-coded values unless 7C is our hard-coded value. Compared to 78. Let's see if we're correct here. I mean, I'm sure it is though. 78x, which is 120. If we go look in the tiles, 120 should be a hard framer. 120, yes, that's a hard framer. So yeah, that does make sense. Are there any other memory locations? D26B. Yes, D26B. This one here. That happens in between Snakies and Almas. And there are others too though, because we have D2A7 here. So D26B might have something to do with either Snakies or Almas, and this one might have something to do with Almas or Skulls, depending on which, like how you look at it, right? So, and that's the first one we saw, right? D26B as one of these unknown variables. Okay, I'm going to see if I can break on that. Okay, initialize round, that's fine. Okay, that's where we were, sure. Oh, do we not? Okay, we never stopped there. Probably because there are no snakies in the level, perhaps. Let's load one with snakies. I think the next one has snakies. No, the next one doesn't. Neither does this one, nor this one. I guess I'll have to load the first level by resetting the machine. Okay, let's see if we break. Yes, we do. D26B is loaded. So it is snaky related. That's weird, because what could be special about snakies when it comes to like initialization of the level? So we're loading this and we're jumping in a function. So let's follow this function, 68CD, sure. Oh, and we are at position 2C1A, right? Okay. We are passing 1 in the accumulator, which we are immediately decrementing. Also weird because there are like four snakies or 3 snakies in the level. We load the working position, which is 2C1A, into DE, sure, okay. And we're loading E into the value of HL, which is pointed to D26B. Okay, so we're copying this, are we? Yeah, so we're copying the Y position, increasing HL, and now we're copying the X position, right? Yeah, so we're making a duplicate. Okay, we're just making a duplicate here. Why would we do that? I'm going to back in here. 6ACD was it? Okay, that's weird. It does loop a couple of times, increments HL. Conditionally based on the parameter to the function, the first parameter. That's weird. So yeah, this simply duplicates our working position here to the next 2 bytes for some reason. I mean, I guess we're just making a copy, right? But I don't know why that would be relevant for the snakies. 1A, 2C. Okay, I'm going to give this a name, which is 68CD. Yeah, so this duplicates the working position to the following 2 bytes. Yeah. And we then go back to where we were. And then, yeah, let's give this a name too, D26P. Wait, that's not... D26P should be, like these guys should be here. Okay, I need to resort this because these aren't properly sorted. Welcome back, Alberta. Yeah, so this is these guys just duplicated, D26P and C, and these are duplicates. Y and X, okay, ABC, okay. And then these have a name too, yes. It's compared to, so we don't have a result here, but it's ANDed and compared to 90. So there's a 9 in the front. Oh, and that value is put in D1FF. That's interesting because we don't know what D1FF is either. D1FF, that's this one. If that position, and which one is it? Loading C into A. Okay, so that's what's happening now. C would be 88. Where does that come from though? Not sure about that. Wait, we haven't done that yet. Well, no, yeah, C is 88. And we're ending that. Get just the 8 and check whether it's 90. Load 1 into A and A into 1 and D1FF. Okay. We are not going to do this, I assume, because this comparison didn't work. And the result is 1, okay. Oh, and we do not. Oh, does it know how many of the different mobs are in the level? Perhaps, though, I don't know. And then back to 0. Again, 88 compared to B8. Okay, it's more involved than I thought, but oh, it has to do that for every tile, right? So that's probably what it's doing. Like, is this a snaky? Is this a skull? Is this a Medusa? Otherwise, it wouldn't increment the counter, right? Or would it write it down into the proper memory address? Okay, let's go back. Okay, now we're midway. Sure. I mean, the snaky there's one snaky here, perhaps. I think we're now here. And it's probably going to stop here then, because that's where the next snaky is. No. No. But it was indeed here though. Okay, so we are back to initialize round. Okay, that was what we were looking at, and then that's our little loop. D2B1 we did not find, right? D2B1, that wasn't clear. Oh wait, no, we have an LDIR here. We're clearing memory again. Okay, important. So this copies call data, I think. So let's see. Let's first load this level, and this shouldn't do anything because there are no calls in the level. Well, no, let's do the next one. Or maybe, yeah, do we have goals now? I think the third level has goals. No, it doesn't. So D2B1 has no information, and we're copying this into goal 1 position, which is D064. Yeah, we know this data here. So this is all the goal data, but there aren't any in this level, so this copy is not going to do anything. 1E bytes, right? That doesn't do anything. Well, wait, D2B1. Yeah, that's this one. Yeah, nothing is copied here, and it's 1E bytes, which is 30. So 30 bytes. Wait, so let's see. 30 bytes for the goals. Goals were at here. So 1, 2, 3, 4, 1, 2, 3. Yeah, 3 times 10 is 30. Yeah, okay, so we have 10 goals and they take up 3 bytes each, meaning we have to skip 30 bytes, or we're duplicating 30 bytes here. Now let's do this in a level where there actually are goals. That makes more sense. So that's level 3, so we have to just exit level 2 and have to finish the level. Okay, now let's see what is in this area here. Still nothing. Oh no, initialize round. Okay, and then we're gonna stop. Yes, now there's data here, and this is actually, so these 30 bytes, including the zeros, are the goal information, right? So this is the position, right. I guess I'll have to figure out where this is copied from, because it does seem to be that the data for the levels in the ROM isn't like all in the same neat order for some reason. Because yeah, this is integrally copied into our goal data up here. If we look, so if I do this, this array will appear up here. Yes, so there are 4, and this is the data. So 12 bytes of data, identical to here. So D2B1. I mean, I don't know why it just does that for the goal positions or for the goal data. That's very weird. Six, 7 CF. Oh, that's down. Okay. Yeah, I'm gonna just note this down. So these don't overlap, right? D293. Yeah, that's like here. It's going to be the information for the skulls. D27F. Yeah. So this is all information that's copied into this giant array above. Why it couldn't be copied straight in there, I don't know, but that's how it is. Okay, so let's just give this a name, D2B1. Yeah, we're in the wrong position again because I have another section, I think. Yeah. Yeah, it's this one then, D2B1. So this is level initialization goal data. Okay. And I think that's going to be it for tonight, as it's quite late now. So I thank you for watching, and I will be back